Hey pre-algebra students, Mrs. Ratsberg here. So we are moving on to problem 1.2, representing decimals as fractions. So last lesson we talked about just identifying the fact that fractions can be written as repeating or terminating decimals. Now we're actually going to be going in the reverse, though it won't feel like it as much. We are going to be looking at decimals and trying to identify the fractional equivalents. But specifically, our focus question today is, why is it possible to represent every repeating or terminating decimal as a fraction? Hopefully you know that answer based on the definitions we talked about yesterday. But if not, you'll at least see some really cool patterns in this lesson. And honestly, I didn't ever think about these patterns until I looked at this lesson. I kind of thought about it. It was kind of weird, but like, it's really cool. So try and pick up on the patterns. It's really neat. Okay, so what we're going to do first is part A. You're going to see the following table, and you're going to write each fraction as a decimal and make sure that you use that calculator. So just as a reminder of that, when you type things into a calculator, using Desmos, it's very clear because you can just write the fraction like 1/9, and it's going to give you the decimal equivalents immediately. But also don't forget, if you use that division symbol on your calculator, like the divided by symbol, if you click 1, click the divided by symbol, 9, you're going to get 1/9. So what you're going to do, when I say go, I guess, you're going to fill out this table here. So 1/9 through 7/9, and then 1/11 through 7/11. Write out the decimal equivalences. You are allowed to use repeating lines if you want. So like if certain digits repeat, draw a line over them. That's totally fine. Then you're going to describe any patterns that you see. You might notice that the ninths, so the 9 in the denominator, the bottom number, might be easier to tell than the 11ths, and it also might be easier to use in words, because I think that's the hardest part. It's hard to identify in words. So go ahead and do that now. Okay, so hopefully you realize I'm not going to, so I'm just going to do this quickly. I'm just writing my answers. I'm going to stop there, because hopefully your entire table is filled out. Okay, so I am going to ask for some volunteers to identify what some patterns are. So ninths, who can tell me? Great! The repeating number is the numerator. You notice that like 1/9, the 1 repeats. 2/9, the 2 repeats. 3/9, the 3 repeats. 4/9, the 4 repeats. How cool. And then what about, oh my gosh, I can't, like my handwriting has gotten so bad. I'm sorry. Let me try again. Okay, 11ths. This pattern you might notice, but it might be hard to describe. So go ahead, someone or someone's, give it a go. Yeah, good. I have no idea, actually. I'm just pretending here. So, so the repeating value is the numerator times 9. Right? 1 times 9 is 0, 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. And that's just a really cool pattern. And something I want to note, because that's all you've seen so far, but this only works if we have a proper fraction. So I'm just going to write a star and say must be a proper fraction. So that means it has to be less than 1. But the main part has to be less than 1. Otherwise, like, if we had, you'll see this later, but if it was like 12/11, it's not going to be 12 times 9. So it wouldn't be 0.108108108108108, because for starters, 0.108 is less than 1, and 12/11 is bigger than 1. So just things like that. Okay, so in part B, you are going to use the patterns You found in part A to write a decimal representation for each rational number without a calculator. Then I want you to check those answers. All right? And then we're going to move on to part C as well at the same time. So then in part C, you're going to find a fraction equivalence for each decimal, if possible. Just be aware of what you see. So using those patterns, you're going to do parts B and C. And then for part D, you're going to just tell me if those items are true or false, and then we'll come back together. All right, so hopefully you have all that done, and you're not just going to copy what I'm about to say. So 9 over 9, you should have said, using the patterns would be 0.9 repeating because it's ninths, and the numerator is 9. But on your calculator, if you did 9 divided by 9, you only would get 1 because 9 divided by 9 is 1. But 0.9 repeating is painfully close to 1 because the 9 repeats on for infinity. So there's really no other way around that. Negative 10 ninths would be negative 1.1 repeating. 10 elevenths would be 0.90 repeating or 0.90 repeating. And negative 12 over 11 would be negative 1.09 repeating. Okay, so then for part C, the fraction equivalents, the first would be 1 and 2 ninths, then 2 and 7 ninths. Whoa, that looks like a G. So sorry. 2 and 7 ninths. Number 3 would be 9 over 11 because 9 times 9 is 81. Hopefully you noticed that number 4, not so possible. There's a pattern, and that pattern repeats, but it's not a repeating pattern. It goes 2, 7, 2, 7, 7, 2, 7, 7, 7, 2, 7, 7, 7, and it's going to keep repeating. So this would be not possible. 5, 1.99999. Notice how there is no dot, dot, dot. So it would not be 1 and 9 ninths. It would be 1 and 9, 9, comma, 9, 9, 9. And then because it's a terminating decimal, what you do is if you were to name this decimal, then however your decimal place, the smallest decimal place, becomes your denominator. So tenths, let me use a highlighter and be really, really tiny about it. So tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So that means my decimal is 100 thousandths, or 100,000. Okay, and then 0.999999999 for number 6 would just be 9 over 9. Okay, and then for part D, both of these are true. All right, and then finally, why is it possible to represent every repeating or terminating decimal as a fraction? And the reason is, folks, that all repeating and terminating decimals are rational, and all rational numbers can be written as fractions. Okay, so that's it for problem 1.2. So at this point, you need to go and do your daily practice for today. That should be on your Canvas page, and please let your teacher know if you have any questions at all. Have a great day. Bye-bye.